Let's take an example of sales order processing. When you create a sales order, the basic tables are updated. The examples of basic tables are VBAK, the sales order header, VBAP, the sales order item, and then so on and so forth. If you are from a MM or PP background, think of a production order. A production order has some header data, item data, scheduling data, so on and so forth. Same thing with MM. MM purchase order has header data, line item data, partner data, so on and so forth, right? So these are the basic tables that are updated. So far, so good. On top of that, SAP also updates the index tables. Example VAPMA. This table is called orders by material. So if somebody wants to view all the orders for a particular material, you can go to VBAP, VBAK and grab those. But it's a very expensive operation. So, right at the time of creating the order, SAP updates this index table, VAPMA, that's optimized to pull the data of orders by material. That's why they are called index tables. Another example, VAKPA, orders by partners. Give me all the orders for Walmart. Again, you can grab them from VBAP, VBAK, all those base tables. But again, it's an expensive operation. So SAP knows that pulling orders by partners or materials is an expensive operation, number one. And number two, these are required operations. They are required because they know that these reports have been pulled since ERP system has started. So they have delivered all of them by default, and whenever an order is created, these entries are made. Want to see more examples? LIS tables. If you have done credit management in sales order processing, you'll know that S066. This is an example of open order cumulative. What's the total open order quantity for a particular customer? You can grab them again from VBAK by aggregating all those tables or all those rows and then saying, okay, this is how much they have ordered. But no, that's an expensive operation. So SAP in parallel makes an entry and updates S066 table with the open order cumulative quantity. Same thing with S067. This is open delivery and billing. Same thing, cumulative. Why are these used? To calculate the total credit that has been consumed by a customer. Total open credit in terms of open orders, open delivery, open billing. And that's being compared against the open items and the credit limit, so on and so forth. There's a whole business logic that happens. What is the point? The point is the entries made in these tables are because dynamically calculating the open items from VBAK is an expensive operation. So, at the time of creating these orders or updating these orders, all these tables need to be updated. You want more examples? Let's see. There are status tables. These tables exist in every functional area: SD, MM, FI, CRM, PP. In sales, they are VBUK, VBUP. Header level statuses, item level statuses. Statuses are simple things like, has the order been delivered? Has the order been billed? Anytime there is a billing, this table needs to be updated to billed. Anytime the delivery has happened, this table needs to be updated to delivered against the corresponding order number. And then we have the due lists, right? They're also part of indexes like delivery due list, billing due list. This billing due list could be per material, by shipping point. And then we have output data like NAST. All outputs need to be stored in the table, NAST. So this is how the index tables, LIS tables, status tables are updated for every single order. Now let's go to MM. Now in MM, if you take the material document, there is a material document header, MKPF, right? And then MSEG. These are material documents. Now, does it end there? No. There are so many index tables, history tables, aggregate tables, valuation based tables. For example, in history, you write something to marred H. That's a history table. What changes have happened to this document? How about totals? MARD, I believe. And then valuation. MBEW, DWH, and then there are index tables. Again, what is the point? The point is the same data that's in here is being repeated in these tables only on an aggregate basis. Meaning, what is the total value of material documents by plant or stores location? And that is being stored here. What is the total valuation? That's being stored here, right? If you go to the sales order processing, all this data is mostly changes happening to the base tables. Some change happened here, you go and update these tables. And these are called typically aggregate tables or aggregates. Now, if you compare the basic table, let's say the basic tables are 5 tables in sales order processing. The aggregate tables are 100 or 500. The actual data resides here. This is the basic data. Just because we are not able to retrieve that data in time with the current database techniques, we are doing so much of aggregation and writing so many redundant aggregate tables. It's the same set of data, just being repeated again and again and again because we want the data in that format. It's like Play-Doh. This is your original Play-Doh. And then these are all variations. You can make many shapes out of the Play-Doh, right? But the original material is the same. Any change to the original material is being recorded in the original tables or original structures. And then all these changes need to be replicated and propagated to these aggregate tables. And this is the primary root cause of all the development complexity. This is where the problem starts. And because of these aggregate tables, this results in huge, I'm putting it in capital letters, huge database tables. If you go to your ERP system, standard SAP ERP system, there are close to 100,000, a little less than that, transparent tables. I'm not talking structures, I'm not talking any of that stuff. The basic transparent tables, there are 100,000 of them. Can you believe that? Does an ERP system really need 100,000 tables? Because of the way the aggregates are written, It's become so complicated. There are so many tables that are required because extracting data or meaningful data from the base tables is complicated using the current database techniques like Oracle, Microsoft SQL, Sybase, so on. And on these tables, there are probably 15 to 20,000 index tables. What is an index table? Let me show you some examples of these tables. All right. If I go to a table like VBAK, which is the standard SAP sales order header table, VBAK. So if you are an MM or PP consultant, you can imagine the standard header and item tables. Click on display, then go to indexes, and you'll see that for that table, there are so many different index tables. Index on this column, index on a group of columns, so on and so forth. So why have these index tables? Why does a table, like a sales order header, for example, have indexes or indices? And by the way, these are all credible numbers. You can just go to the tables behind the scenes. For example, if you want to look at the list of database tables, you can go to something like DD02 or DD02L. It's a table, and then search for all the list of tables. Same thing with indexes or indices. There are tables where all the indices are stored. So you can just go verify that these are real numbers. Almost close. Just maybe rounded some of them, but they're very close. So coming back to our question, why do we need index tables?